Hello, hello. How's everyone doing today? Oh, wait, the fan is off. Is on 1 second. There we go. Should be much better now. Everyone doing okay today? So yeah, this is day 27 of studying compilers every day until I land a compiler role. We're getting really close to a month actually, which is really cool. So yeah, the plan for today is pretty much more of the usual. At this rate, I don't think I'll ever get to the open source stuff on stream, but at least I'll be still able to do leetcode, and I will be working on toString stuff today because last time I think I got the MIR construction implemented. So now I want to be able to at least see what it looks like, and then from there we can have some fun with implementing other sorts of algorithms that help along with it. Let me fix something real quick. Yeah. Okay. So I got straight into leetcode. Let me put this over. Okay, hopefully the daily is not that bad today. I really don't want to spend a year and a half on it again. Okay, this looks pretty straightforward at least. An integer n, return any array containing n unique integers. Okay, well, sure. So let's use a set. Set of int. What's good, Seb? Do you go by Seb or Sebastian? Hopefully this leetcode is rather brisk. Let's call this visited. Okay, bet. Oh, wait. Oh, add up to 0. Oh, I see. I see. Okay, I actually have to look a little bit closer then. So for an odd number, so if we have an odd so I'm thinking if we have an even number, we can just like add any positive numbers and any negative, or their negative versions. And then if we have an odd number, yeah, any any array is crazy. The only interesting case is if n is odd. Oh wait, we can include 0. This is no longer interesting. Okay, I thought 0 was like excluded or something, but if we can just include 0, this is a little bit trivial. Okay, n is at least 1. That's the only other. If n is 0, that would have been a little bit interesting, but yeah, this problem should be pretty smack dab easy. And 1. So if this is odd, then we want to dot push back 0, and then yeah, we can just do that, and then we should dot push back. We can do. Actually, let's do 1 so we don't have to do as much math. Let's do less equal. So we want to push back I, and then want to push back negative I. Surely this is within like time bounds. Yeah, okay, sure. I'm curious if there is a faster way to do this. My sources say no, so okay. LeetCode done in 5 minutes. This is a good stream. So yeah, now we get to implement some fun things. So let me get this pulled up real quick. There was a lot of debugging that was happening last time. Yeah. Oh, did I make a change? This is in driver. What did I change here? Oh, I formatted. Sure, okay. So just catching up from last time. The two big changes we made first is that we changed the structure of MIR a little bit. So in like previous intermediate languages for the compiler that I've had, so the AST and then, which is like the literal memory representation of the program, and then the, I guess, desugared or simplified version of that. In both of those, I tried to maintain like variable names to the best of my ability. And to be able to do that, I ended up having to, whatchamacallit? I wanted to avoid string comparison as much as possible, because in the future I want to do some sort of like static analysis stuff. So the best way to avoid that is just by having like a symbol table, sort of. And like that's nice and all, but we don't really need that anymore at the optimizer level, because function names are still nice to have because they're pretty trivial to preserve, and we're not really going to be changing the functions that are produced. But the control flow graph, like basic blocks will be really awkward to give names, and variables at this point we don't really care about preserving names wise. So the things we've changed here are the function doesn't have it doesn't have like an ID for a name anymore, it just straight up holds a string. And then basic blocks don't have an ID anymore because I realized it was a bad idea. And then the changes to instruction were that the big one is call. Instead of taking like a function ID, I realized I could just, where did it go? It's up here. I realized I can literally just give it the function pointer. So yeah, that will be the plan for that. So given those IR changes, I also finished implementing the stuff that lowers from this desugared AST / simplified AST down to the optimizer IR. So like there's this whole slash. There was like a whole lot of debugging that happened, but that is done now. So now what we need to do is, if we go to like my big test directory, and if I were to use like this sample program, which contains pretty much everything in this language. If I were to build, which is just the make file, it doesn't print anything, and that's because we don't really have a toString implementation yet. So hopefully we can get that done today. That is the ideal state. So yeah, this goes in HR, I believe. I had like this toString visitor thing in, actually in HR, I just realized this goes in MIR. Yeah. And here I think I had some sort of a nice toString visitor. Yeah, this thing. But that doesn't map one-to-one because our IR does not map one-to-one. So I will be changing that. As in, I will be implementing it differently here. So this is an instruction visitor. It's public and private stuff. Do we need prefix here? Why do I even need prefix here? That's really confusing. Okay, I mean, I guess I could just nuke it. It's just a symbol table and res, so I can actually just get rid of that. What we at least need is, oh, I can't type. We need get result. We need a constructor, I think. I don't really know what to put in the constructor, so I guess I will just leave that for now. I think all of the information should be already encoded, so we don't really need any external stuff here. So we want to steal the existing visitor for instruction in here. Yeah, this imports from there, so this is actually perfectly fine. I think we can just steal the stuff in here for the most part. Yeah. What does the middle end? Yeah, I should probably give the whole compiler design little spiel. So, imagine you have like, also I will be like writing with my mouse, so bear with me. So, let's say you're designing a compiler, and at first you're designing it for C, and then you want it to output like x86. So it's like simple enough, you can just go 1-to-1. But then the problem is you need to like, if you wanted to extend it, so let's say you want to support like C++, and that's fine, you just like write another compiler. And then like you want to support like, let's say a different assembly architecture, let's say like ARM, some dialect of ARM. So then it's like, okay, sure, we can just write more compilers and stuff. And that's like fine and dandy. But each time you write it, you have to like re-implement all of the like optimizations and stuff. And then like there's a lot of duplicative code in the I guess like straight up code gen at the end. So let's get rid of the arrows real quick, because I didn't plan out this drawing very well. And then let's say like x64, which is x86 64, but yeah. And then like if we keep extending this, let's say like we add Go. So given this, assuming we have like M front ends, and then we have, or like M source languages and N backend languages, the number of compilers we would have to write here is M times N. So that's like really annoying, but it turns out there is a way we can do this that is, that minimizes the amount of work we need to do. And the idea is to have this middle end language here, which I guess the term of art is like intermediate representation, which is abbreviated to IR. And then the idea is, instead of having to write each individual combination of language to assembly, we can just write 3 sort of like mini compilers from source language down to IR. Let's use purple for these arrows. And then for each of these backend assemblies, we can just write another half compiler from the IR down to that. So then, instead of having to write m times n compilers, we can just write m plus n compilers. So this is like the foundation of, I guess, like 3-layer compiler design. And you can kind of split it up based on these arrows. Also, we can include another arrow here just from IR to IR, and this is like optimizations. So looking at these arrows that we have, this is a nice color, sure. So these purple arrows here at the top here, these are the front end. This optimizer arrow here, this is the middle end. Where do we put this? Let's put it here. Yeah, perfectly written. And then these purple arrows down here are the back end. Yeah, my mouse writing is struggling, but this is like the brief overview of like compiler design, roughly. So what we've done so far in this project, so I have it divided out into front end, middle end, and then like driver is just like everything that holds everything together. But the front end here, we create an AST, which is like a literal memory representation of the program. So I guess we can break this down into like mini arrow 1 AST. And then the way we get to the AST is we have this like giant parser slush. All of this is like using a library to generate a parser pretty much. This was not fun to do, but it's kind of inevitable. So we have like, so this arrow here is the parser. So we have this AST, and then to make it easier, and I guess like a little bit less messy to generate the IR from this, I have a second, I have a sort of intermediate representation, which I call HIR, which is like high IR. Very creatively named, but it breaks down some of the more complex structures in the AST. So we have like HIR, and then we've written the thing that generates down to IR. So the existing box we have is like pretty much this pile here. Yeah. So we are currently working with the IR. Anyways, thank you for coming to my TED Talk. Yeah. So yeah, so we've figured out IR generation, but now I want to be able to see what I have generated, so I would very much like to implement toString to some degree. So the way I'm gonna do that is with another visitor, because I have been very visitor pilled. I did not grab water. I will fix that issue later. Good explanation, thank you. I'm not even gonna begin to try and explain visitors right now. That's like a whole separate can of worms. Is this all your implementation, not like Kaleidoscope? Yes, this is completely from scratch. Where did I put this? Okay, so I'm in MIR. Yeah, so I need to be in here. Here? No. Here, yeah, okay. What am I missing? I see. I have a different import tree, I guess. So I would need to for declare instruction visitor. Incomplete type? Oh no. Oh no, okay. This does not bring me joy. Okay, what do I do here? I could try importing this, but we're gonna have some circular dependency issues, I think. Let's try it. So this is instruction.h. Oh, wait, that works? No, that doesn't work. Yeah, because then that happens. Ah, this is a mess. What's good, Max? How do I resolve this? Because the problem is, both of these want a complete class from the other file. What do I pull out here? This sucks. This really sucks. Maybe I just pull out the visitor even. That might be the least messy. Yeah. We'll just do this for now. Yeah. Yeah, we will deal with this little ugly mini thing here. Let's see, I need to steal this. I need to namespace this. We need to include instruction. Redefinition? Oh yeah, I see. So then this needs to import that. Oh, this is becoming really ugly really quickly. So we can that doesn't work anymore. Yeah, because this is circular now. Let's see. Well, this is not convenient. Okay. So this isn't gonna work. I'll just keep this for now. These are pretty tightly coupled. I don't really think there's a good way for me to take them out. What did I do there? Sure. Okay, let's not worry about that for now. Let's just leave that in case I need to keep it for actually using it. Is there a way I can resolve it in here instead? I would need to like forward declare all of these, which is a little bit messy. Yeah. Unless I go back here and forward declare function. Yeah, for reference, apparently I cannot just like import function in here. I guess I could try it again. This would import or include. So this would include instruction, and then we can get rid of these two. And then we can get rid of this here. And then we would need to we need to do that. If that works. I swear there was a reason it didn't though. Okay, well maybe I was just like dying of exhaustion last time, but let's try building real quick. Okay, well it builds, that's surprising. And it runs, okay. Is there a memory leak at all? Okay, nice. So funnily enough, this whole messy thing I did last time was completely unnecessary. Which is unlucky, but it happens. So we can happily go on our merry way implementing the toString visitor here. So we want result. Yeah, okay. Okay. How did I handle like recursive calls up here? This would be in here. Oh, that wasn't an issue, so that's fine. But it was an issue in scopes, I think. Did I just make a new visitor each scope? Yeah. Okay. So I use the same visitor, but I just made a temporary variable to store the result, and then I set it to that. Okay, sure. So we want to be in. I want to be in here. Yeah. So let's start tapping away at this. I think we just need a program toString even. Yeah. How do I structure it up here? I want to be consistent. Being here. Okay, so the function had a toString. The program had a toString. Presumably the program one just called toString on each of the functions. That wouldn't really work that well here though, because we'd have to resolve previous functions, right? Oh wait, no, it already has pointers, so that's not a concern actually. Yeah, okay. So we can start writing really heinous code. So let's just get result. This is a string. Okay. So the easy part's done. So now we have to deal with it for all of this slush, which is like not bad. Just need to do it 5 times. I think I need it for just like the default as well, if I'm not mistaken. I wrote a visitor somewhere. Unless that's just like bad interface. It was in here. Yeah, this, because the visitor in here also just had a base instruction one. I'm not sure if I need that for dynamic dispatch, so we'll just try it without for now, and then have a mental note that that could be something that will fix a bug potentially. So yeah, I want the header so I can read from it. Maybe if I just steal all of these. Let's do that. Yeah, and then we can J. That, and then we can do that. So let's start with binary op because that's the first one in the list. So we don't need the header up anymore, but I would like to have this up at least. So what does this need to print? This would need to print some variable. Oh right, we need to create names for things because a lot of things here just literally do not have names. So yeah, we will have to resolve that somehow. Actually, we do actually need to have this open again for a second. So we want counter. Counter, and then we want vector of, we want a map because we want to map pointers to things too. So we want to map the pointer to each basic block to a counter, so we can just like keep reusing that. I'll just make one for basic blocks for now, even though we're not really gonna need to do that because we don't really have control flow. So it's just a single basic block. So I don't think we're gonna need to have any like branch stuff, or at least stuff that has to print another basic block ID. If we do, then something has gone terribly, terribly wrong. But let's just do this for now. Hop on Linux. I'm stuck on Windows on this machine because I want to play Valorant still, but my laptop is running Arch. So we map basic block to that. Do that. Need to include cstudent. Mac update? Unlucky. What? It's copy construct. What? Do I just turn this into a void pointer and call it a... Oh, right. Basic block pointer. Okay, well that solves that. Yeah, if it makes you feel any better, updating Windows is no better. And whenever I attempt to update on Arch, I find out that the Arch Foundation is being DDoSed for some reason. So, like, tough. The functions already store their names, but the instructions don't. So we need instruction pointer, and this needs to be instruction mappings. Unless we can have IDs. Okay. I think that's all we need for this, at least on this side. And then just every time we call counter, we postfix increment it, and it should be big chilling. Yeah, okay. I could also just make a helper to map things here, because it just occurred to me that there will be a lot of duplicity there. So let's do int 64t. Solve basic block. We can do that. And then we can do the same for instruction. Writing basic block is really getting annoying. I should just be using like abbreviated names for everything. It's like BB, I, F, P for program. Yeah, well, we will leave it as is for now. It's a problem for future me to deal with. So let's implement those two real quick, because I think that should be pretty quick. So actually, we can still run this macro on these, right? No, we cannot. Okay. So we check the mapping. Theoretically, we can just check the mapping, and if it exists, we just return the number. If it doesn't exist, then we add it to the thing with a new number, and we return the number. Yeah, so we can do, so ID is, so we want basic block IDs dot count. Find in map. That's good, kid. Good to see you here. Oh, this website full blinded me. Mom, dad, and bro. My map. Yeah, find is not what we're looking for. Has contains, I see. Oh yeah, it does have contains. Neat. Good comms. So if this contains, has that. Actually, no. Yeah, we can just do if that. Return. Actually, maybe I should just use find, because then I only search once. Yeah, I might do that. How did I do it before? Because I feel like I did something similar with like a resolve. I think it was in here? Why'd I write a helper for that? That was really dumb. Why did I do this? For those of you wondering why this is a bad idea, since it's in a separate helper function, we can't actually like... I don't think it's inlineable, which means I don't think this like duplicate access can be optimized away. This is like really dumb. Okay, we're gonna avoid this. We're just gonna use find. Yeah, I really liked the bracket operator there. Oh, I wrote this while I was like trying to not do work in like the final week of my internship because we'd already presented to like 3 different people. That's why. Okay. So we want auto. So iter equals basic. I just found this. What are you working on exactly? This is a C to x86-64 compiler, and the primary focus of this project is to become familiar with middle-end and back-end algorithms. So things like register allocation, tree tiling for like instruction selection, and pretty much just like everything in the middle end, because that's where a lot of my knowledge is the weakest, and I want to at least try and implement a lot of like LLVM optimization passes by hand, or at least like some of the basic stuff. So we want dot find. Love the dedication, thank you. So I want to find basic block. Iter. Ugh. So if iter is basic block IDs dot end, then it's not found. But we can do a little bit of like, we could do a little bit of flattening here. We can, let's just do some code duplication. I'm listening to you while you're coding, keep up the hard work, thank you. Hopefully this inspires other people to also keep working on their own personal projects as well. Have you done constant folding yet? I had that to mine recently, it's pretty simple. It seems roughly pretty simple, yeah. I want to make it like a middle and pass though, more formally. At least that before, whatchamacallit. Or I want to make it like a formal pass rather than just like a peephole thing. We can even not equals here. Yeah, because this should be like the early return. Value type 2 or dot second. Oh, whoops. There we go. We can debrace this a little. So then we're going to add the basic block mapping, and then we return the new mapping. So we do basic block IDs at basic block equals counter plus plus. We can new ID. We can just do this once here. Oh, whoops. And then we can return new ID. And then we can kind of just do the same thing here, but with instruction pointers. So let's just steal all that. We want to change all that, I guess. Instruction IDs dot find instruction. It's funny that they're like the same length, actually. What's good, Tryhard Casual? Good to see you. So we can, let's change this. Yeah, okay. So that's that helper done. So now it should be a whole lot less miserable to implement this sort of stuff. How is your progress so far? I have sort of scaffolded out all the toString stuff I wanted to do today. And I'm just now getting to implementing the actual fun things. So this, so what do we want this to look like? We want it to look like percent whatever. So we want the var equals op, and then left type left, right type right. So I'll keep that in mind while I am creating this. So we want, oh, it just occurred to me, I'm gonna need like toString for like value and all the different value things as well. Okay. I could even generalize this down to like resolve value instead of resolve instruction. Yeah, because these might also be literals, so we might have to do a little bit of dynamic cast slush, which is unfortunate, but that's kind of how it is. Yeah, because we're not resolving instruction always. We're just we're potentially resolving value. I think this gets a separate thing. Do you have x64 code gen yet? No, I am just dealing with genning IR right now. Because then I can like maybe start writing like tests. I think the IR spec will be pretty stable. Type has toString, so I don't need to worry about that. Maybe I should just make a value visitor instead of like an instruction visitor here, huh? No, I'm overcooking. I'm definitely overcooking here, I think. I'll just implement this first without more helpers. If there's something duplicative, which I suspect there will be, because left and right will have to be dynamic casted in some way. But if there's something duplicative, then I'll handle it from there. Yeah, so we want so we want to resolve instruction, the current instruction, I think. No, yeah, we should turn this into value. This is stupid. Actually, we'll just try it first. I'm like trying to overcook way too early. So we want. So we want var equals solve instruction, and this will be this. Okay, wait, what is... Oh, not this. I. Yeah, so this we need toString underscore string. Yeah. Yes, did. Okay. Windows or Linux, which do you like? I enjoy using Linux more, but Windows is kind of just an unfortunate reality of the world. So here we are. So we want toString that, and then yeah, I can definitely turn that into a helper. Equals so I get left get type, and then we can toString this all. It's an arrow. Yeah. And we can just preemptively do write type as well. And then we want left equals we want more boilerplate. That's what we want. If dynamic casts it to a literal. Yes, I know dynamic cast sucks, but we don't really have a way around it here, I think. Literal start. Our value is not polymorphic. Are we tripping? Do I import value? In here? We do not. We don't? Wait, what? can import at the top here. This is it's broken here. It's not reduced. So we want this to be a literal star. Do you have a virtual destructor? Oh, wait. I figured I could just use the default here. But I guess I do need to virtual this. I need like a... we want value just default. Can I just... Oh, I need... Okay, we're figuring it out. Okay, so let's put in literal star. No, we want... Yeah, perhaps. Let's just throw this into ChatGPT and see what it says. Because I am somehow out of my depth. Unsurprisingly, actually. How do I make value polymorphic? Yeah, okay. Is that it? Implement. Oh, I see. And then so what's the implement? Oh, duh. Okay. Okay, so I don't even need that there. So I think if I just do that, right? If I just default that, that's good to go. Okay, well, obviously not. Enum on the base class and static cast accordingly. Yeah, I mean, yeah, it's always just kind of doomed, to be honest. Value star. Oh, I didn't virtual this. I might be the best. Anyway, we figured that one out quite quickly without too much misery. Yeah, that one's really unfortunate, but it happens. Okay. Neat. Okay. So if left exists, then that is a literal, then we can just return left. Right, not return. Yeah, we can do that. So this is left, get value. Wait. I need to string this, I think. Right, because this is a long, yeah. Okay, well I think we found our helper function that we need to write. Do this, and then else. We want toString resolve instruction. Oh, I will need to handle function params as well at some point once I implement them. I feel like it should be a meme at this point for me to have to account for function params, because I just have like, if we just search grep to do, literally all of these are about function params. But I've just been like holding off on trying to implement that. Which I think on one hand is fair, but on the other hand it's like, bruh. So we found our little helper function that we want to write here. So let's get that done real quick. This goes in here? No, that's the same file. It goes in here. So we want string. We can just do this. I don't know. I guess. Yeah, and then we can just generate that one. And call that a day. So we can replace this with toString of I. Also, we need to implement it. Let's put it here. This seems like a nice place. So this is value. So we can probably just steal this thing. So we have literal L. So we have dynamic cast, and then if L exists, or I guess if L is not a null pointer, then it's a literal, so we can just return this. Otherwise, we return this thing. Solve instruction, and this takes V, I guess. Can I just static cast this? Yeah, we can just static cast this even. It's not related? Oh my god, wait. Oh, I just realized. Right, because instruction isn't always a value. Well, this was not enjoyable. Yeah, so we can't actually do that. We couldn't do it down here either, so that's not a loss, but this sucks. This really sucks. I mean, what if we just... This is a pointer, right? What if we just give it a void pointer? toString, let's do static cast to void star v. So we have that static cast, and then we want resolve instruction. So let's instruction star this. Nice, okay. What could possibly go wrong here? Reinterpret cast? I guess I could. Also, this is the wrong one, yeah. Interpret cast to instruction. Instruction star. Yeah, okay, nice. Let's do that. Let's keep it hacky here. This is always the best. So this is, yeah, that should be L. This looks good. Like, it doesn't look good, but it looks good. Can do that. Let's add one more to the to-do list. I guess this is an SSAR, so there aren't really like variables insofar as like the instructions themselves would be the value. Yeah, okay. It's also a little bit interesting right now because I don't really have variables yet, or like even just like a straight up like. I guess like I have stack variables, so they're a little bit ugly, but they're just kind of wrapped in loads and stores, I guess. Yeah, so you can just do this, I guess. Is that fine? That should be fine. toString I think that's good. Yeah, so now we can start fixing this mess up. So let's get rid of this. toString. And this is I get left. What is going wrong here? Yeah, include type. Oh, duh. I see what's happening. What's good, Janine? Got back safely. We want value to string. So this would go in here. Nice. Good shit. Oh, I'm eating my burger? You're so up. Did you say hi for me? We can do this now. And then we don't have an overlapping symbol. Jippy. So we can do this. And then we can steal this again. We could even get rid of this duplicative thing here. Yeah, and then we will just have the variables also contain the type. We will just preserve more information in this IR. The goal is to like mirror LLVM's IR, but not necessarily copy it one-to-one. So value type equals toString of v get type. And these will always have a type. So we want v type plus space plus that. Also, undercurl is like broken on this, which is unlucky. Another L for Windows. So you have the type plus the space, then the name. Wait, if this is a literal, then it doesn't have a type. So that doesn't make sense. Actually, does it? Let's open a dot bolt. Perfect, actually. Let's see. Yeah, it does have a type. So we can keep that. Plus, and then we want space. You can even just space character plus. I want the % character for the name. And we want to add that. Yeah, that's not the prettiest code I've written, I will say that, but it'll do the job. Yeah, okay. I will also need a label type, I think. Yeah. It looks like that's something that will be useful in the future, but until then, future me issue. Yeah, I see. So we have this, and then this means we can get rid of this, like, that thing. We can get rid of that thing. We can do result equals bar plus equals plus left plus we need the operator. So let's go here, op. So we can just toString this, I think. Yeah, this seems coherent. Okay, so we have add that, and then I'm gonna eventually add like an unsigned keyword, but I'll figure that out when the time comes. That might be an interesting next thing to add. So we just add at left and then right. So that's that one. Yeah. So the call should be like pretty easy to do. How does LVM do this? Just in theory, if we were to second num. This needs to be above. It's down here. Call and then print function, I guess, sure. Yeah, I might just straight toString function as well. I guess like, yeah, that's a little bit more complex now actually, because I can't just like, Function get call string, I guess. I don't know. We'll make that a thing. For now, what if we just tested with a binary op and then these three and then a return. I'll worry about calls later. You know, assembly, I have a very rudimentary knowledge of it. Actually, no, this shouldn't be that bad, because we just steal the name, yeah. So we want this. I think we want this for all of these at least. So we can do that, and then the load has one. So the allocate has like the literal pointer. The load has that. Store just doesn't have it, I think. And then obviously the return doesn't have it as well. Yeah. What's good, Libby? Good morning to you. Okay, so the call shouldn't be that bad. So the function name and the function type. So we want string fname equals f type even first. Hi. Get collie. 3 AM here, so I'm gonna leave. Good luck on your compiler. Thank you. Have a good night, or good morning, I guess. Collie dot oh, but here we can include the actual thing, I think, right? Do we already have that in here? mir.h. Yeah, we do have that in here. So we want Corva. Yeah, we need get name. We need get type, and then type get type, and then name. So it's string get name. Oh, I just formatted all that away, I think, right? No, that's the header. We're fine. But what we do need to do here is we need function or type. Function, get name, get type. And then we want string, function, get name. There we go. Yeah, we formatted all that away, but that's whatever. But now we can get collie dot get type. And we can get name this as well. Get collie, get name. We want to result equals var plus space equals. Let's make this comma space. Space, and then percent for the variable. Sorry, virtual register, depending on who you ask. This needs a toString as well. I'm moving a little bit quicker because it's a little bit bland. So var equals. We literally have call, I think, right? Yeah, we have to literally call plus f type plus space and plus f name. So I think that's good for that. Yeah. Var equals. I could even make like a string builder helper, but I feel like that might be a little bit unnecessary at the moment. This allocate is a little bit boring as well. So we have the allocate type, and then we have, I guess, size or alignment. But yeah, so we have var, and then we have string allocate type equals I, and then we get alloc type. Let's shorten that a little bit. And toString this. Wait, what? Yeah, so that's a type. Oh, I see. This is typo. Result plus or equals var plus equals allocate plus alloc type. So that's a little bit straightforward, and then we get to pretty much do the same thing here. There's like a little bit more interesting stuff here actually. String. So we want, actually, let's test I. Yeah, so there's just a pointer in it type, which, yeah. But that is there's the load here. Load. So we have, does my load have a type here? Or is that kind of just implied? Yeah, okay, it is just implied here. Yeah, because it has a type, so surely. Yeah. So we want good string. This is load. This is putter equals. Want to value to string. And we want I get putter. So var plus equals load, and then putter. Yeah. All right, now I have store, which is a little bit yawn. So what do we have to work with here? Value and putter. Let's paste that in here. And then store is a value and then the putter. Value. So then we have result equals var or store, and then value plus comma space plus putter. And then this final one, we want ret. So we should just have a value equals value to string. It should be v or t. Get value. So then we have result equals ret plus value. It should be good on this. So for all the instruction visitors, at least, we're good to go. So what else do we need here? We need to like actually make the thing. It looks like. Or I guess we need to call this recursively. So basic block needs a toString. And then function needs a toString. And then program needs a toString. I think that's how I organized it in the previous ones, at least. Yeah. Yeah, everything has a toString. Lovely. Yeah, so that goes in here. So we want to, let's start implementing these. Basic block. So we can just like keep implementing these upwards, I think, and it should be quite bearable. What are all these pings? 1 second. Okay. So we want function toString first, or basic block toString actually. Let's do it string. Basic block toString. So then we want we need to account for indent as well if we were to print this. Do I need to? Maybe I'll just make this take an indent as well. Or like, let's do it string prefix something. Yeah, that seems sane enough. in case I want to just like print it straight up. Yeah, let's get rid of this actually. I will just, if the need arises, I will implement it. Alright, it's a very thematic thing that I need to learn how to do more of. Okay, so we want so we might as well just give it the name here. Because the basic block doesn't really come with a name. Yeah. So res, this should equal, how much indent do we want here? We want 0 indent actually. So we want name. So new line, then for yeah, we can just do 2 space indent for now. Auto I in so we want body. Yeah, we want for I in body. So we want toString visitor T or V visitor. Yeah, we implemented it in here as well, right? So yeah. Yeah. Wait, something's not checking out here. Yeah, this is fine. That seems roughly right. And how did I deal with the whole most specs and parse issue here? Is there an HR to MIR? Yeah, I just defaulted the constructor, I think. And then, did I also do it in the implementation? No, okay. Yeah, okay. So I can just default the constructor here. This comes in here? Yeah, okay. So toString visitor, just default that. Oh wait, this is the wrong place. Whoops. So we can do that. Let's go here. Let's do that. Oh, right, whoops. Do that. That's fine. We can just do this, right? Right? Let's look at what I did before again. Shouldn't be an abstract class. It should have implemented everything, I'm fairly sure. Alright. Interrupt, call, allocate, load, store, return. Oh, wait, I see. Right? Yeah, that's not an abstract class anymore. So here we want to return res while we're at it. So for auto I, we want to visitor.visit I, or how did I do this? This is a instruction star. Is it that? Huh? Auto. What? Okay, we're really struggling here. Auto I in body. We should be able to just visit, right? I accept. Oh, now we call accept. Oh, I see. Wait, so I'm actually doing it wrong in the other ones, I think. Right? There we go. And then we want res plus equals two space indent plus I dot or visitor dot get result plus new line that should be good for this even. Yeah, I should also fix the stuff in everything else as well in here. So this accepts. Yeah, this is not it though. This should be I accept at visitor. Yeah, so we have that. So each instruction, and then we need to so we want this. We want terminator accept visitor, and then we add that, and then we should be good. All for each of these? Yeah, that should be it. Yeah. So it's basic block, and then Yeah, that's good. So then the function is wrapped by braces and the other function shenanigans. So that's good. Now we need function toString. And then this does what does this take? This takes we need define we want to get all the other components. So the string function, the function, I guess we can just call it type, equals type or to string, and then we pass in type, or what is it? I think we keep type in this at least. Yeah, it keeps type. So we want function type. Wow, I can't type. Wait, what? What? Am I tripping? Like, this should be in the correct namespace. What? Oh, wait, I see. God damn it. Yeah, we can do that, I guess. Unlucky. Type string. And then what else does this need? This needs the name, which we have, and then params, which we don't care about yet. So we want body, just sleep. It is not even 9 o'clock here. So we have auto basic blocks in basic blocks. We should actually just assemble the res at the top. So I want define. We can steal this. Where are you streaming from? I'm streaming from the US. So I have type at plus name that. And then we want opening brace. Format that for now. You can add the obligatory function params to do. We need a new line here. Res plus equals basic block toString. And then we want, oh wait, that's a problem. This should also take a visitor, I think, right? We can just entry for now. Just do that, I guess. As programmer, I didn't know there were very much dedicated rules that involve making compilers. There are actually quite a few. Not as many as like web dev or just like traditional software development per se, but there's enough for it to be feasible at least. Whether it be like working on the large mainstream compilers or something for like proprietary accelerators or proprietary hardware. And we add a new one. I forgot to add a colon there. Maybe we just figure out numbers here, and then is entry, or this is just a bool. String name, if is entry, then name equals entry. What is wrong here? Oh, this is, whoops. Else name equals should put this at the top as well, actually. Visitor dot get next ID, I guess. Identifier. We should make that as well. And this goes in here, I think. Resolve. So we want int 64 t get next identifier. And we should implement that real quick. It's pretty trivial. It's just a postfix increment. So then it goes under resolve instruction. Turn counter plus plus. This is toString visitor. Yeah. what's wrong here? This is out of line. I changed this from name. This is so this takes pool is entry equals false, I guess. Are you making a compiler from scratch? If yes, then what do you aim to compile with this? Yes, this is completely from scratch. The goal is to compile C into x86-64. Currently the subset of C is like really small, but I intend on extending it to at least most of the interesting stuff that isn't just like front-end slush. Or I guess like I intend on adding all of the language features that meaningfully affect the optimizer and the backend code generation. So this should also be toString. 2_string. This seems about right, so then, yeah. Oh wait, we can use a ternary operator here. Is entry, then it is entry, else we have that thing. Yeah, there we go. So this takes name. There we go. So it's entry or next identifier. Yeah. And then, yeah, none of the rest of this is like particularly noteworthy. I will need to add this basic block to the mapping, I think. Oh, wait, that's actually very inconvenient. Yeah, I guess that's a future me issue as well. Yeah, because if we're referencing like control flow with other basic blocks, that might get a little bit messy. But we don't have control flow yet, luckily, so I will gladly defer that issue to future me. Yeah, so that's still fine. Yeah, we need to figure this out. Are you willing to open source this in the end? The repo is currently public on my GitHub. This looks good. We can just do this for now. We need a new line, actually. Yeah, that looks good. So then, as we add just the closing brace, I think. Turn res. Just do that. There's too many spaces there. I don't like that. Let's do this. And then finally, we need program toString. So we just iterate over function in f or functions. So we want string res plus equals okay. I would like these nice like line breaks, so I will res equals function 0 dot toString. And then we want for auto header equals f dot begin or functions dot begin plus plus actually no, we should prefix increment that. That actually matters there. Okay, not equals functions and header plus plus. If functions dot empty return empty string new line and then plus header dot toString can return res. What's wrong here? Arrow. Whoops. I don't know why I decided to do it that way. Why is this wrong? This is in the wrong... What? Wait. Oh, this is a... What? Okay. A little snafu done. I should do... I may as well do the same thing in basic block real quick. Or not basic, like in function. There should be at least one basic block, so I don't think I need that check there. We want basic blocks 0 dot toString. This takes in entry plus new line, or not new line there. Actually no, this does take a new line, I think. Yeah, because we will always have a thing on the end. And then header equals basic blocks dot begin, and then we will prefix increment that in a second. Can do that. Do that. Header to string, and then this takes, oh yeah, this is also wrong. This should be true, I think. Yeah. So then this should take a new line in the front at least. We can just double new line at the front. And then we can new line here, and then we can get rid of this little thing here. Yeah, that looks more sane. We need to prefix increment this. Yeah, that looks about right, at least. I think that's everything. Yeah. So let's call this in a driver. Okay. A little bit nervous. I feel like something is very tragically going to break. Oh no. Bad Alec. Okay. Where is the bad Alec? Valgrind? Oh. Oh lord. Okay, so maybe the pointer was the void cast was probably the mistake here, if I had to guess. Oh crap. Okay. Let's use a simpler test. Let's do test one line. Okay, that works. That doesn't do what I want it to, though. Is there a memory leak? Yes, okay. Destructor, oh. Yeah, I don't actually free the pointers, so I need to do that real quick. Let's see, these are managed by the basic block. So we want a destructor there. And then this goes in. This will go in mr.cpp, yeah. Then we want basic block. We want to, for auto I in instructions, or body, we want to free I or delete. Whoops. Then we want to delete terminator. And then what? What are we double freeing? Declaration? This should have... What? Oh, I think this is double freed, right? How do we create this? That might be why. Current instructions. So what happens to this? When do we add it? We want to... This is on the return. I think this clear is what's ruining our day here. That's good, Mr. Pillars. I am debugging my everything pretty much. This should be fine, right? Invalid read by the destructor. The terminator is an invalid read. Or the destructor for the terminator is invalid. It's to destroy at that. What? Okay, this is like fair. So do I not need this? Because that seems wrong. Yeah. Oh, wait a second. There might be something I'm forgetting to push to body, perhaps? No, I do need to free all these. I definitely need to free these. So we do need that, but something's invalid about that. why? Okay, I'm throwing this into ChatGPT again. I'm like really struggling here. Do I have? Yes. Wait, what? When was this being called before? Function. I'm just gonna give it everything. I don't want you to think. Oh, wait, I see what's happening now. Yeah, that should... Oh, wait, I see what's happening. Yeah, there's some pointer invalidation thing happening, I think. I really should be using smart pointers. This is actually just my bad design choices biting me right now. Let's feed this in. Yeah, okay, that makes sense. This might be a next time patch scenario. I might just like start making things with. I might start using shared pointers. This is so stupid. Such a bad design choice on my end. New. Use shared pointers. Share a unique pointer. Let's throw that in here. Okay, I guess that makes sense. unique footer with unique footers inside. Okay, that makes sense. Yeah. Which one am I doing first? Get char to mr. There was one other random change. I think it's in HIR. Yeah. This was the other random change. Move extraneous prefix string. Implement toString. Something's crashing right now. You don't use AI? I try to avoid it in terms of like actually writing the code, but if there is something that I'm like trying to debug, I very much do just throw it at ChatGPT. Yeah, I try to avoid it as much as possible. Yeah. I think that's a good place to stop for today. I think I've stared at this for long enough. Thank you all for showing up here. If you're new here, make sure you like the stream and sub to the channel. It really helps out with the algorithm. And while you're down there in the description, you should join my Discord. That's the best place to chat with the rest of my community and to get notified when I go live every day. Yeah, feel free to ask the question. Also, while you all are in the description, make sure you connect with me on LinkedIn and add me on GitHub. And of course, join the Discord. Please join the Discord. Yeah. You can also just ask me on the Discord, by the way. So, yeah. I will not be sleeping for like the next 5 hours, so like it's whatever. Yeah, I gotta get food though, so yeah. Take care, y'all. If you have any questions, ask on the Discord. Take care, take it easy.